Hey, my name is Tanveer, and today we are gonna see like if you have downloaded a very large model like 405 billion parameters model or 300 billion parameter model, okay, and you want to use it for inference, or you might have trained your own model and you want to like host it for an inference so the other people in your organization can use it. This large model can be so large that it cannot fit in one GPU. So the way to scale is like you get a machine with multiple GPUs. There are situations in which a model cannot fit in all the GPUs in a single machine. For that, you would have to go for a setup which requires multiple machines containing multiple GPUs to host this language model, and this is called as a distributed inference serving. So we are going to take a look at it, and we are going to see the configurations. So the way that I'm going to structure it is to talk about the configuration, okay, is to see like which model I'm going to put it up, okay, and what kind of libraries and setup is needed, and the kind of consideration. So let's go to the first. I'll just briefly talk about the challenges of large language model in hosting a large language model for the inferencing. So the first of the challenges, these models are so large that there is a high latency. What do I mean by the latency is the time taken, the flight time, okay, from you fire a request, okay, and get a response. So that's the latency, okay. So and we often do an inference on very large amount of the data, and so the latency is a big problem there. The second thing is low throughput, okay. So each request would have very long sequences, right? And a lot of time it takes, it's seen that the time taken to generate each token is very long. So token generation time should be fast, okay. So that's the throughput. And you have seen like you might have used an Hugging Face API for doing an inferencing, and it's usually very slow while the inferences. And the third thing is significant memory consumptions. So these large models are based on this attention mechanism, right, which basically requires three very large matrices: the key value matrices, the value matrices, and the query matrices. Okay, and if the memory management is not done in your inferencing framework, right, you can often get an out of memory OMs. Okay, while doing an inferencing over a large sequence, or when you proceed, right, say you start with 20 examples and your code will work, but you want to do an inferencing over 1,000 examples. If the memory management in the framework which you are using it for an inferencing is not done properly, you are going to get in this out of memory errors. Okay, so these are the three challenges. So what we want is low latency, okay, high throughput, and good memory management. These are the three things which we want. Plus we want a flexibility in the framework, and better control, and easy scaling. These are the things that we'll look for, the things while we are doing a distributed, or not even a distributed, like inferencing or a large model or a large model. And one more thing that we need to ensure that the way that we are like serving the model, okay, it's served in a way that a lot of people can consume it. And if you change an underlying model, okay, your application code which basically consumes this model doesn't change. So the best way to do it is using an OpenAI completion API format. So basically, this is a very standard API which OpenAI has created. And if you expose your model as a REST endpoint, okay, then you will use an API which is compatible to an OpenAI and all the frameworks like LangChain, and you can use your own code base or own framework to make those calls. And even if you change from if you change your underlying model, let's say from Mixtral 8 cross 7b to Llama third 3b, your application code is not going to change, because you might have written the code in this format. Okay, so that's another thing. So the configuration that we are going to look at it is one machine. Okay, this is second machine. Okay, there are like this multiple GPUs, 7, 8, and there is another multiple GPUs. So we are going to load a model across these two machines. Okay, across all these GPUs. And that will be available as inferencing as a REST endpoint. So that's the configuration. So we'll take two machines. So for the setup, okay, what we need, first of all, we need to establish passwordless SSH. So this machine should talk to this machine without password, and that has to be done using by setting SSH. So the way you set up an SSH is like generate the key, generate the key, copy the public key to the other machine, to authorize keys, and there you go. So this way you can establish a passwordless connectivity. The way we are gonna execute this thing is via this method. So we have this machine, okay, and we have this machine. So the libraries that we are gonna use are the two libraries. One is vLLM, okay, and the second is Ray. So we'll use this two pip installs. Okay, set this up. So you need to install vLLM on this machine and Ray on this machine, vLLM on this machine and Ray on this machine. Once you install it, okay, the next thing that we would need to do is to copy the model weights. So you need to copy your model weights. I would like weights on here, and you would have to copy on here. The thing that we need to ensure, the weights are copied at exact identical path between the machines. Okay, so if you are copying it on a slash folder mnt slash data slash models, the weight has to be put on the same locations on these two machines. Okay, once we do that, okay, what we need to do is basically create a Ray cluster. So I have these two machines. This is machine 1, this is machine 2. or maybe A and B. I'll make it A and B. Okay, we have vLLM here, we have Ray here, we have weights here. Same, we have vLLM here, we have Ray, and we have weights. So what we are going to do is we'll make this machine as Ray master. Okay, and we'll start the Ray service on this machine. And for this machine, okay, we are basically we'll start the Ray, okay, and we'll ask it to join this master. So these two machines will become a part of Ray cluster. Okay, Ray is a framework, vLLM is a framework. We are gonna see about those frameworks in some other video because I want to keep it quick and short. So this is what we are gonna do. And once this is done, okay, we'll basically start the vLLM base OpenAI compatible test server. So this is what we are gonna do. Okay, so we are gonna see like how to do this actual distributed serving, distributed inference serving of a large model. Okay, so I'm on. I logged on to like my both the machines where we are gonna put a large model so that it will use the GPUs of both the machines. Okay, so I'll just check it out. I have like what 8 GPUs here. Okay, come on. Okay, there are 8 GPUs here, and I'll just check it over here. There are 8 GPUs here as well. So we'll put the model in a way that it's basically using all the 16 GPUs for the serving. We have seen the training part earlier, but here we'll see the serving part. Oh, come on. Control auto. So for the first thing that I need to see like whether I'm able to do a passwordless SSH between these two machines, and we'll just check it out. We'll see if the SSH is on between the machines. Okay, so SSH is not running here, but SSH is running here. So I'm gonna start the SSH first. Okay, so I'll go here and we'll do an SSH start. Okay, and the SSH status will give that the SSH is running. So the SSH is running. Okay, now we'll check the SSH between the machines. 172, 31, 15, 13. It's connected. Now SSH 172, 31, 11.213. It's connected. So SSH seems to be working fine. Okay, that's cool. Oh, I did another exit. Okay, so on this machine, okay, on both these machines, I need to have the vLLM and I need to have the Ray, which I have already installed it, but I'll show you. Mamba activate vLLM. So if you don't have it, you can write pip install vLLM. It will install the vLLM. If you want to install the Ray, you can write pip install Ray. It will install it out. Okay, in my machines, I've already built those things, so we don't have to wait. So import vLLM. Oh, sorry, I 3 L's. vLLM. It's importing. I'll check the vLLM dot version. Okay, it's there. Import Ray dot version. It's already there. So you need to like build those two things. Okay, the next thing that you need to do is you need to keep your model weights at the exact same locations. Okay, so I'm gonna use this mixtral model. Okay, and we are gonna host the mixtral model for both. Okay, so if I do a PWD, this is the exact same path. This is an exact same path here as well. Let's make it a bit bigger. So I go to Mixtral. Okay, this is the path. I'll go and check it out there. My model is at the exact same. But if you don't have it, it's not gonna work. So that's the second thing. The second check we have checked it out. Now what we need to do is basically we need to. I'll just go to CD, the home directory. Now what I need to do is I'm gonna make this machine as a ray master, okay, or I'm gonna trigger the ray on this machine on a specific port, and then I'll ask this machine to join the ray cluster of the first machine. Okay, so I'm gonna start the ray. It's very simple. Okay, so this command says, okay, you need to start the ray, and this machine is your head machine, okay, or your master machine, and you need to start it on a port 6379. Okay, so I just started the ray, and the ray seems to be started. I'll just check it out whether the ray is running. Okay, so I'll do a ray status, and I can see there is one active node here, okay, and the ray is running. Now I'm gonna ask this machine to join this ray cluster. Okay, so this you need to do it by this. Okay, so you need to put an IP address of this machine, which is a private IP address, and the port on which the ray is running. So we'll just start it. Okay, the ray is started. It says the ray runtime is started. We'll do a ray status. So ray status says like there are these two nodes. I was able to see this node earlier, okay, which is itself. So here this thing refers to this node, and this thing refers to this node only. We'll do a ray status on the first machine as well to see. Okay, we'll get the same thing. So ray is also started. Okay, so we have ray on both the machines. Okay, I'll just start NVIDIA's me in a loop here so that we can check it out. Now we are gonna run the actual command to basically start the OpenAI compatible REST server. So this is my OpenAI API server. Okay, this is how we are gonna invoke the vLLM. Okay, to start the server, this is the model name. Okay, that we need to basically do it. Okay, where this is a path basically where we need to load the model weights. This is a tokenizer path where we would have to specify where the tokenizer model is. This served model name is an important parameter because if you use an OpenAI completion API, okay, it asks you to give you a model name. Okay, and that model name has to match with the model name which you are using to make a call. So let's say if you are making a curl to do a REST call, or you are writing a code to do a REST API, there is a parameter called model, okay, which has to contain a name, and the model name, whatever name you provided here, has to be replicated over there. Here we are saying like, okay, it needs to listen to an all IP address port 3000. The REST server will be available at the port 3000. Then the GPU memory utilization, here we are asking it to see like how much GPU memory it need to use. So I'm saying like, okay, you need to use a 90% of GPU memory. Here if you get an out of memory exceptions, okay, it can put some of the codes on the RAM, some of the weights on a RAM as well, okay, in the page attention. So you can reduce this number if you are getting an out of memory exceptions. But here I am using it zero point 0.9, which is the default value. Tensor parallel size, it basically says how many GPUs that you are gonna use. Okay, so this tensor parallel size defines the number of GPUs that we have it on machine. Okay, on one machine. So I had like 8 GPUs on my one machine. So I specified like 8 GPUs, and these are the GPUs where your model is gonna host it out. So if you have a single machine with multiple GPUs which you want to use, you would have to like change this number appropriately. The second thing is like this pipeline parallel size. This will be required when you want to use a multi machine and multi GPU kind of a setup. So we have like for this video we have like 2 machines, okay, where we are gonna do a distributed inferencing, and each machine has like 8 GPUs. So this total number of GPUs is like 2 times 8. Device equal to CUDA tells, okay, that we are gonna use the GPUs, since CUDA is a referred device. So we are gonna run this command, okay, to basically run an OpenAI compatible server. Before that, I just want to make sure, like, remind you of all the things. Okay, we'll do a quick check. So we already verified this passwordless SSH between the machines. This seems to be working. Okay, so this is check. Maybe I'll write this is check. vLLM and Ray is installed between on both the machines. Okay, this is check. Copied the weights to an exact same locations on both the machines. This is also check. And we started the race service on both the machine. The first machine is an head machine, okay, and the second machine, when we join, we ask the second machine to join the first machine as a part of ray cluster. So this is also checked. So we'll just switch on to the machines, okay, and we'll fire the command to start the OpenAI compatible REST server. And once that starts running, your model will be available as a REST endpoint. Okay, so I'm gonna paste it out. Okay, and there you go. So it's gonna take a little bit of time, okay, to start it out. So it says like driver IP 172.31.15.13. Okay, then we have this thing as model. This is a configuration parameter. This is this tokenizer. So it's gonna take a little bit of time to install it out. I'll just do one more thing. This is the machine, right? This is the one. It's not NVIDIA. It's MI minus L over here as well. The utility of using this OpenAI REST compatible API is you can basically change your underlying model. Okay, so if I want to move from Llama 2 to Llama 3 or Mixtral to Llama 3, okay, we can just quickly change it out, okay, by modifying the underlying model, okay, your application code. So you wrote a RAG application which basically does some sort of an LLM prompting, right? So you don't have to change your RAG part. The only changes that you would need to do is in your the model serving. So okay, so here it started loading it up. Okay, so we can see, okay, it basically connected to the second machine. I'm on 13, okay, but it has connected to 213, and 1 minute, let me check my audio source. Okay, my audio source is good here as well. My audio source, okay, audio source is good. So here we can see like the model is being loaded, okay, on both the machines. We can see like the GPU being increased up. Okay, here it has almost used the 90% of memory. I'll just expand it for a while. Okay, you can see like it has taken almost 90% of memory. Okay, 36 out of 40, because we specified that parameter. Okay, and the GPU server is available. So we can see like this 8 machines, these 8 GPUs from this 213 has been completely occupied. Okay, and I'll just go and check the other machine as well. 213. Okay, and the first machine itself right here as well, the GPU has been occupied. So now we are gonna just yeah, and we can see like the server is available, and it's basically available on inferencing on the port 3000. So I'm gonna go here. Okay, I'll just stop it and we'll fire a curl command, okay, to see whether the server is inferencing or not. Okay, for that I would need a curl. Where is my curl? Okay, I'll take it from here, the curl command. I don't have it here. Okay, do I have it here? I don't have it here as well. Okay, I copied it here. Let's increase the number of token to say 500 and the temperature to 0.6. Okay, now I find a REST request in an OpenAI compatible format. The REST request is going through. You can see, okay, there is a response code of 200. Okay, and it just answers it. So we have seen like how to expose your model, okay, on multiple machines with multiple GPUs and use it for inferencing. So you can add like more machines. You just have to like install the Ray and vLLM over there. You can copy your model weights over there, and then you can ask your machines to join the cluster. If you like it, like, feel free to subscribe and stay connected, and thanks for the watching. Thank you.